You've probably seen protein powder before, in a kitchen cabinet, a gym bag, or a shaker bottle after a workout. It looks simple, just a fine powder in a tub. Add water, shake, drink, but that scoop has taken a surprisingly complex journey through biology, agriculture, chemistry, and engineering. To understand it, start with protein itself. Protein is a nutrient your body uses to build and repair tissues and support muscles, skin, organs, enzymes, hormones, and parts of the immune system. Proteins are made of smaller units called amino acids, tiny building blocks arranged in different patterns. We get protein from foods like milk, eggs, fish, beans, nuts, and soy. Protein powder is not magic, and it is not required for health or muscle building. It is mainly a convenient way to add protein to a diet. The most familiar type is whey protein, and it begins with ordinary milk. Milk contains water, fat, lactose, minerals, and two main protein groups, casein and whey. During cheesemaking, enzymes help milk separate into solid curds and liquid whey. The curds become cheese. The whey, once treated as a low-value byproduct, contains useful proteins and amino acids, so modern factories capture it instead of wasting it. Milk is collected on dairy farms, chilled in tanks, and transported to processing facilities. There, it is tested for safety and quality, including temperature, freshness, fat content, and unwanted microbes. Centrifuges spin the milk to separate cream from the liquid. After cheesemaking, the liquid whey still contains mostly water, plus lactose, minerals, and traces of fat. Now food science takes over. The whey is pushed through filtration systems like microfiltration and ultrafiltration. These membranes separate materials by size, concentrating protein while reducing water, lactose, and other components. Less filtration produces whey concentrate, which usually keeps more lactose and fat. More filtration produces whey isolate with a higher protein percentage. Hydrolyzed whey adds an enzyme step that breaks some protein into smaller peptides. To become powder, the concentrated liquid enters a spray dryer. It is sprayed into a tower as tiny droplets while controlled hot air evaporates the water almost instantly. The dry particles fall and are collected. Then come mixing, flavoring, and testing. Food scientists may add cocoa, vanilla, sweeteners, salt, stabilizers, or blending aids. Quality control checks protein content, moisture, contaminants, microbes, and label accuracy. Plant-based powders follow a similar path, starting with peas, soybeans, rice, hemp, or seeds. The plant material is cleaned, processed, separated from fiber and starch, dried, flavored, and tested.